everyone, my name is Daniel Khan from class 5 STEM 1, and today I will be presenting at Maths Pbl 2022 chapter 2 differentiation. Today's question is: a multinational beverage company holds a competition to design a suitable container for its new product, coconut flavored drink. Designing a drink container competition. Criteria for the design of the drink container are as follows. The capacity of the container is 550 cm3. The shapes of the containers to be considered are cylinders, cone, pyramid, prism, cuboid, or tube. Vertical shape is not allowed. Material required to make the tin must be minimal. The container must be unique and attractive. Drink price rates. Join this competition with your classmates. Follow the criteria given and follow the steps given below. Suggest 3 possible shapes of the containers. For each container with a capacity of 550 cm3, show the dimensions of the containers with their minimum surface area. State each minimum surface area. Choose the best design from the 3 designs to be submitted to the competition by listing down the advantages of the winning design. So, 1. Suggest 3 shapes. The 3 shapes that I have suggested are the cube, the cone, and also the cylinder. Step 2. Showing minimum dimensions and minimum surface area. So, first of all, we'll do the cube first, which is the easiest. So, given the volume of the cube is 550, and the formula for the volume is x squared plus h, which x squared is equal to the surface area of the base, and h is equal to the height. After doing some algebra, we find out that h is equal to 550 over x squared. So, the surface area of the cube is equal to 2x squared plus 4x times the height. So we sub in the formula of the height that we made, and after some simplification, the surface area equals to 2x squared plus 2200 over x. So after differentiating it, dA over dx equals to 4x minus 2200 over x squared. Since it is minimum, dA dx should be 0. So after doing some algebra again, we found out that x, which is the base length of the cube, is equal to 8.193212706. And if we sub in x into the formula of the height that we did just now, we will find out that the height is also equals to x, since it is a cube, so it all makes sense. So the minimum surface area we find, and we got 402.77240667 centimeters squared. Now we'll do the cone. So given the cone volume is pi r squared h over 3 equals to 550 centimeter cube. So we'll make the height formula, which is h equals to 1650 over pi r squared. So given the surface area of the cone is pi r squared plus pi r s, which is the slanted height, which is equals to the hypotenuse of the base of the radius and the height. So the surface area written here is pi r squared plus pi r bracket times square root r squared plus h squared. So after doing some simplification, the surface area equals to pi r squared plus pi squared r to the power of 6 plus 160 squared square root all of it. And after doing some differentiation, r is equals to 7.187971689. And if you sub in the radius into the formula of the height that we just did, H equals to 73.06808304. Therefore, the minimum surface area is 12,079.71912 centimeters squared. Then now we'll do the cylinder, which is the last one. Given the volume of the cylinder is pi r squared times the height, which is equal to 550. So we'll find the height formula, which is equal to h equals to 550 over pi r squared. So the surface area is 2 pi r squared plus 2 pi r h. So we sub in the formula of the height that we just made, and after some simplification we found out that 2 pi r squared is the surface area. The surface area is equals to 2 pi r squared plus 1100 over r. So we differentiate that equation and we find that r, the radius, is equals to 4.4401155564. And if we submit the radius into the heights formula, we found out that the height is equal to 39.42925244. So the minimum surface area, we submit all the heights and the radius into the surface area formula, and we found out that the minimum surface area is 371.6119451 centimeters squared. So at the end, which one is the best? So it's obvious, right? The cylinder is the best shape that we could choose because it has the lowest surface area. Since it has the lowest surface area, it needs the least material to manufacture it. So the cost to make one container of which is cylinder in shape can be lowered. So now it's the end of the video, and I hope you guys enjoy it. So I'll end this video right now and see you next time. My name is Daniel Han from FlyStem1. Gracias, adios, bye bye.